where this column equals this value. Where is a condition? Where is a condition? Where allows you to be explicit on what data do you need? I'm only pulling data that I need. Now, a real life hands-on example of filtering your data. If you drink coffee and you don't use like a K cup, if you like an OG and you use a real coffee pot like me, you got your coffee, your ground up coffee. You put your coffee, what do you put your coffee in? You put your coffee in a coffee filter. That filter leaves what you don't need and pulls out what you need. So data is the same way. I am selecting my columns from this table where, that's where I put my filter, where this column equals this. That's my filter. So in my output, I'm only going to get what I need. I'm honing in on that today because today we're also going to talk about logical operators. Logical operators are filters, but you're basically stacking those filters. You're saying where this condition is met and this condition is met or this condition is met. And I'm going to show you how to do that. So, but I want to hone in on the ability to filter down that data so you can explicitly know what you're looking for. Any questions on that? Okay. So is everybody able to connect into the VM?
It's always me, right? I have a question.
Who's it?
This is Nicole.
Oh, ask it.
I want to show you something because I don't want to click something that might mess something up. So
okay, I'm gonna stop sharing. Don't recover.
Don't.
Yep. Okay. And the reason that I say that, it's basically you open up Word and Word is like, do you want to see the documents that you already done? That's what that was. Now I'm
I understand. I didn't want to like save something that I shouldn't or get rid of something that maybe needed to say. So
yeah, you good. You good. Okay. So was and I'm gonna move mine too because I don't want you to see. I don't want y'all to see mine because y'all gotta. Is everybody able to get into the VM? And yeah. Okay, good. Let's go. So another thing last week, and I'm gonna hone in on this every single session with y'all. I'm not playing. Every time we meet, we're gonna talk about data relationships and why. It's important for us to have that conversation regarding those data relationships because that core understanding of data relationships is going to leverage you for the rest of your life in data. As long as you're in analytics, you need to be aware of those data relationships. And when I say that, it's going to help leverage your understanding in Python. Python uses data relationships. In Python, you have to merge data sets. And when you merge them data sets, you merging them data sets on a a common data. Python has the data relationships. Power BI, when you merge your data sets in Power BI, you're merging it on a common data set. Excel does the same thing with their pivot tables. Any space within the space of analytics requires a core understanding of you to know how data works and operates. And once you get that, it's gonna make like advanced concepts easier for you because a lot of those advanced concepts are built on data relationships, like your joins and your CTEs and things like that. Those are built on those data relationships. So I don't really play about that because the more you get in the brain of like understanding it and looking for that, the easier it's going to be for you. It's just going to come easier for you. So here we are with this is your server. Remember, our server that's the brain. They keep everything working. Your server down, nothing is working. So this is our server. These are our databases. Like we talked about in our last session, Databases store the data. When you get your role, your layout is going to be similar to this, regardless of whatever client, whether it's Oracle, GCP, Amazon Redshift. Kiana, this go to our conversation we were having the other day. Amazon Redshift, anything, it might be slightly different, but everything is going to operate pretty much the same way. So these are your databases. These black boxes are your databases. Now, for this database, let's go into our orders DB. Yours is called orders DB. We're going to open that up. And in that, you're going to see like all these little folders in here. Your business is your tables. Because remember, in SQL, your data is stored in a table. So we have all these files. Open up your tables. In this one, we have 5 different tables. Now, the way I'm going to coach y'all today is very similar to my goal is to last week it was okay, let's do this and let's do this. This week I'm still going to coach you, but you're going to be doing more driving. And what I mean by that is it is going to require for you to do your data investigation, for you to go and look at things, for you to go and figure it out. And I'll guide you, but I do that for 2 ways. First of all, as you all are interviewing, it is not uncommon for you to have a technical assessment. And they can come, like I think we talked about that in our last session, they can come in a lot of different ways. One way is somebody basically gonna ask you a few questions, but another way is that someone will give you a pseudo data set and with the expectation of you writing a code to answer whatever their business case is. So with that, I think it's important for you to practice like that so that when you are in that situation, it's not your first time experiencing it. Also, in real life, when you do get your offer, nobody is going to come to you and be like, Lorita, can you retrieve this data from this table using this filter? It's going to come to you in the sense of how many records do we have for this claim? If you're in healthcare, it's going to come in the form of were these members, do we have claims that fall outside the what is enrollment period or the active eligibility period or something like that? It's gonna come in the case of that. And you're gonna have to like leverage data and leverage your understanding to answer it. So it's like I'm not gonna use the word groom because it's a negative connotation, but I kind of coach you in the way of your brain already works like that. And if you could think about something similar in your day to day looks like that in some kind of capacity now. And what I mean by that is, unless you're in a role where somebody is like, hi, I need 1, 2, 3, 4, you over there figuring stuff out already. So I want to put you in a position to where you're figuring it out. Now, Priscilla, you done already let me know you don't play about figuring it out, baby. Like to give y'all a little background, Priscilla downloaded her own environment, got her own database, like she a whole DBA over there. So I said all that to say that mindset is gonna take like that's tea for you. Like that's everything for you. So if you in that position to be able to do that, keep leaning in on it because that's what you're gonna have to do, and that's how I coach y'all because it mimics their real environment, their real life. When you get your offer, that's what it's gonna look like. So here we have our 5 tables. Now, getting back on them data relationships. Data relationships are how 2 tables are related. I know we touched on that last week, but we're going to do it every week because it's going to help you. I was supporting she was a QA tester. She was a current QA tester, and she actually ended up getting a data engineer offer based on like the training and her exposure with QA testing. They're already heavily exposed to SQL anyway. So she was in there doing her QA testing using SQL. And do y'all know that like she wasn't doing data investigation and going to look at her data and going to look at her tables and stuff until like after our sessions. She was saying that it was something that she just never thought about. But she was saying that within her data engineer role, how that is a huge lifesaver for her because her brain automatically works now to go over there and look. And I'm like, yeah, girl, in any space of data, you need to go look at your stuff. So in these data relationships, your data is related because we have something in common. Just like in our natural language, if I'm related to this person, we have a common ancestor. It's a cousin, it's an uncle, whatever the case is. Data is the same way. So in this, it's important for you to have a core understanding of them data relationships. And what I mean by that, go and look at your data, uncover, like uncheck your columns and go and look at all your columns in that table. And you can see, do your data investigation. Priscilla, did your data go over there good? You good with yours?
Yes, ma'am.
Okay. Now you see how your columns are defined because that data is not just dumped randomly over there. When you are doing your technical assessments and when you get them pseudo data sets, talk through that. I had a tech assessment last week. I had did one just yesterday. There was a they sent it over via email on CoderPad, and I had to like share all my screens, share my video, share my camera, and talk through my stuff. So in it, talk through what you're doing. Okay, I'm going to look at my customers table. I see that my customer ID is my primary key. Do y'all remember what that primary key meant? Oh God, well, do you remember what that stands for? What that means in the grand scheme of things? You can talk, Jackie. Jackie, oh, you so sweet, raising her hand. What is it, Jack?
Your primary key is like your identifier. It's like if you have 5 Johns in um in a workplace, how do you know this is John Smith and this is John Wells?
Yep.
Right?
Yep. It's a unique identifier. No two primary keys can coexist. This tells me this record is unique from that record. That's exactly what it means. We have our order details table here.
So would that be like the patient's MRE?
I don't know, possibly. Because if you have Kiana and Nicole might be more appropriate to answer this.
It is. Okay.
They say okay.
She's shaking her head. Okay.
Okay, because if you had an MRN, I'm pretty sure two people don't have that same MRN. Okay. Yep. Priscilla, I forgot you in healthcare too. Oh, this is so good. But yep, because if there is a record of data in that table, and this column is unique for every single record, that is what I can bank on to be their primary key. We have our order details table here, and we also have our columns defined here. We have our order detail ID, which is their primary key. Then we turn around and we got our order ID and we got our product ID, which are our FKs or our foreign keys. Do anybody remember what that meant?
They are a primary key in somewhere in another table somewhere.
Yep. They are the primary key from another table. So in this, when you're doing your data investigation, can somebody tell me what other table is this customer table related to and how? Go and do your data investigation. That's called data investigation, what you're doing. Go and do your data investigation and see where your data relationships are.
Okay, so I don't know if it's right, but my customer ID appears in the orders table, and that it's a foreign key in the orders table.
You right.
I'm looking to see if it was anywhere else. I, I think that's the only other table I see it in.
Okay. And you are correct. Okay. You right. Don't second guess it, Nicole. Sit in it. That is your data relationship. Sit in it, baby. That's your data relationship. Your customers table is related to your orders table on that customer ID. That is that data relationship. So, Nicole, I know you already interviewing. So, when you are in a position to where you are asked those questions or you do come up with a tech assessment, first of all, hit me up so we can yeah, touch base.
Do that.
But when you talk through that, give the interviewer visibility to your thought process. Don't just be quiet. What you just said is perfect. So, I see that they're I see that they're related on their field because that gives insight to oh, okay, this person understands data in a real life, past okay, I can do this. This person understands it in the way that it's used day to day. But that's very good, Nicole. Now, if we let's right click our customers table and let's select our top 1,000 rows. Here we got 1,000 records. Y'all remember that top 1,000 is a limit. That's going to limit the amount of data we receive in our output. It's going to automatically do that. Why? Because, especially in healthcare, y'all know how those data sets are, especially when you look at historical data sets. You can have 3 million records, 4 million records, so it's important to limit that data so you only get what you need. Now, this top 1,000, we can go top 10, and it's going to give you your top 10. Top whatever, it'll give you your top whatever. But for the case of this, let's remove our limit in its entirety.
Okay, this is where my mind went.
Let's go.
It says top 1,000.
Yep.
Top what? What do you mean? Like ascending, descending, alphabetical order? Like what was it based on?
It is based on this
Oh, okay. The customer ID.
Yeah, the primary key. You're welcome. Now, we got this all day long. Now, let's say in our data, you only pull over what you need. So let's say we no longer want the country. Let's double dash it out. Let's comment it out and let's execute. Always just comment out your code. Don't delete the columns. Because therefore, if you want it again, you just go back and it's easier to add it like that. It make your life easier. Oh, Priscilla, did you have your hand up a minute ago to ask a question? Or was I tripping?
I think I figured it out.
Okay, you sure?
I think so.
Okay.
I think I got it.
Okay. I was like, I meant to say something, and I had got distracted. Okay, cool. All right. So comment out what you don't need. Cool. Bring it back in. It's just easier to move and maneuver like that. Now, if I was to say I only want customers who are from the state of Tennessee, how would I write my code to capture that?
Where?
Yep. What column, Kiana? I think that was Kiana.
Where after the from line. Mm-hmm. And you say where state equals. I forgot what you said.
Tennessee, yeah. Where state equals Tennessee. Remember to put your strings around your values. This is the actual data that's in the table, not the column. This is the data that's in the table. You got your table, your water bottle is your table, Your water is your actual data in the table. So anything that's in that table is a string because we see a varchar because we see it defined over here. So we have to make it a string so that it knows how to handle that data. So for our first use case, I need a list of customers who are from the state of Virginia. I'm gonna write in the chat. Y'all got that? Okay. Any questions on that? Because we finna go. We finna take it a step further. We finna turn it up a little bit.
I don't know why I can never execute my code.
Let me see, Nicole.
I'm still on state equals Tennessee. Hold on, I'm sorry.
Did you get it?
No.
Let me see. Okay, so where's that? Okay. Anybody want to tell her what's wrong with it?
She's missing the semicolon.
Yep. You got the quote. Yep. Just reply. No, not. Oh, the semicolon really don't matter. My brain heard single quotes instead of the double quotes. The double. What is this quotation marks? Now, Kiana, let me talk to you because yeah, like that. Now, Kiana, some dialects care about their single quote. I mean, their semicolon. Some of them do. Microsoft don't care.
I gotta remember that because you did tell me that.
Yep. But if you were to put a semicolon behind your code, it'll still work. But it's like not gonna break. But it'll work without it too. Nicole, you good?
Yeah, now I'm looking at what you put in the chat.
Oh yeah, Virginia. Nah, I didn't do it. I didn't do it while I'm over here talking. But yeah, some of the I think Oracle does. I also think Oracle is case sensitive too, if I'm not mistaken. I'm not sharing my screen.
I get stuck because when I was in college and I was learning C, that it was very, very like the syntax had to be like 100%. You would get more syntax errors than anything. Like I probably shouldn't even really learn it because the syntax is so hard to get down. So when I learned syntax, I guess I just be sticking to the rules that I learned. But
yep. Yeah. Oh, Priscilla, why I'm finna cry?
I'm so sorry.
It's okay, because I almost start crying. Okay. So, okay, so good.
I'm sorry, y'all.
You good?
I'm sorry to talk to you. So basically, I can't share my screen because I don't have a webcam on my computer, and I'm on my iPad. If that makes sense, iPad and computer. But
it's okay.
We were supposed to replace the Tennessee with VA, right?
Yeah.
Okay. Because it doesn't look like my data on the bottom changed when I did that.
Is your do your data investigation. Look at your output. Does your output only return records that meet that condition?
No. Oh, I think I canceled out the country part. Let me try.
Oh, like you removed the make sure you but it'll still show the state though, Jackie. Can you post your code in the chat?
Yeah.
Okay, let's do that. And I'll put it on my screen.
Okay. I'm sorry, y'all. Bear with me.
It's okay. This help. First of all, from this moment on, don't nobody apologize for asking no more questions.
Okay.
I do. What's up, Priscilla?
Jackie doing that, I do have a question.
Okay.
Okay, because all this, I guess I'm concentrated on lowercase and uppercase.
Right.
Does the system automatically change that, or is that something we need to do since we're executing?
Now, Microsoft does not care. Microsoft does not care about case at all. Like even in my if I was to do that, it'll still execute. Microsoft does not care. Some dialects like Oracle does. Some of them do. It just depends on what your environment is. So in Microsoft, it doesn't care. Like even the way I wrote my state, it's not the way that it is in the okay, so let me see Jackie code. It's not the way that it is. So some of them do. So did they answer your question?
Yes, ma'am.
So Jackie, this looked right to me. Now what you say was wrong?
When I push it, it doesn't show me. Or do I? Oh, Lord.
Yeah, I'm like, ain't nothing wrong with your code. You good?
I forgot to push execute.
Oh, bye, Jackie. Yeah, I'm like, ain't nothing wrong with it. Okay, so you good. Now, let's take it a step further and let's get into our logical operators. So, what are logical operators? Logical operators are the ability to be able to combine multiple conditions in SQL. Give me a list of customers who are from Virginia and who joined between this date. Give me a list of one in healthcare. Give me a list of patients who came from this provider and who have claims outside of their active enrollment period. You are doing multiple things. Now, the beauty of logical operators is it gives you total control over your data. It allows you to get extremely specific in what you need and how you need it. But with you learning it, when you hear questions, literally, like I said, I wasn't gonna say. Okay, first of all, I feel like I say literally too much, so I'm trying to be intentional on not saying it. But anyway, when you hear questions, be intentional on breaking them down into small pieces. For example, when you are looking for, if you have a business case and somebody tells you a business case that sounds huge, it sounds like I got to write code for 36 minutes to answer this question. Start big and go small. I don't know if y'all watch Snowflake, but it's a clip in Snowflake where Franklin Saint say, I built this brick by brick. That's how you literally have to write your code brick by brick. You go through, you pull one condition, this works. Okay, now I'm gonna add this condition, this works. Okay, now I'm gonna add this condition, this works. Okay, and you go line by line by line. And we touched on that last week because not last week, but in our last session, because if you recall in our last session, you were writing the code and then you were turning around and going to test it. Then you were writing the code, then you were going around testing. And I did that so that your brain can work in pieces like that. So our logical operators are multiple conditions. But once you get in the swing of things, it's essentially just layered. And when you look at code, you can look at, I've written stored procedures that are 800 lines of code, 500 lines of code, and they broken down. But when you go through line by line, it's like, okay, if I glance at this would be like, girl, what are you doing? But if I look at this piece by piece, I know exactly what you're doing. Logical operators allow you to do that because you're essentially just layering that logic right on top of it, like a lasagna. I'm going back to food. It's like, but you're essentially just layering those operators right on top of each other. So logical operators, they allow you to combine multiple conditions. Now, when you combine in those conditions, you only say where one time. You don't keep saying where. You say where one time. So the top logical operators are and, or, in between. I know we use not a lot and in a lot, but I'm gonna just break down each one. And when you looking at this code here, what is the output of this code? What business case is this person trying to answer when they write their code?
They're trying to find people who work in IT and make less than $50,000.
Yeah. And I want my data in my output to meet these conditions. In our natural language, if I say I want this and this, that means I want both of them. Code is the same way. It has to meet this condition and this condition for it to be included in the result. And if you want to filter it down and say where department equals IT and salary is greater than 50,000 and employee last name Smith, and you just keep writing it until you get what you need. Or you say something, Priscilla? You good? Okay. Oh, I thought somebody was saying something. Or, are you good? Or ensures that at least one of those conditions are met. It can be this or this. This or this. And if I come down and say and this, you can layer it right on top of each other. But or ensures that at least one of those conditions are met. I take this or that. I always try to relate it back to like your natural language. I want this or that. Or it's the same way. Notice that when we are applying our conditions, we using these columns because everything go back to what? Tables and columns. I want this column where this column equals this, or this column equals this. Not negates a condition. Another way to do this, and you probably done seen it if you're exposed to SQL, is this here. That exclamation point and that equal sign. You basically saying not equal to. I want all the records from this table where the department is not IT. Between used to be really weird for me. And I don't know why, because like we use it in our natural language, but between used to be really weird for me, along with joins and like, I don't know. But between is you're essentially checking a value that falls between their range. It can be a range of dates. It can be a range of like integers, like how we have here. But if that value falls between a specific range, I need a start and an end. And IN is also very common as well, because N allows you to check and see if that value exists in a list of specified values. That's big in healthcare too, because all those ICD-9 codes, all those different codes and things that might categorize into one other thing. I want all the data from this table where the data is any of these values in this table, in this field. These are logical operators. Once you get like the grand scheme of things, It's layering. We talked about filtering last week. This is an extension of that. In session 3, we're going to take it even further with doing subqueries, which is an extension of this. Like everything kind of builds upon the next. Any questions on these logical operators? All right. So we're going to stay in our orders DB for this use case. Okay. And I'm going to give you all a use case. I'm going to type it in the chat. And first things first, when I type this use case in the chat, go and do your data investigation. And what I mean by that, go and figure out which tables answers this question. Okay, I'm going to ask it in... Okay. So for the use case, I need a list of shift orders where the total amount is greater than $300. I need a list of shift orders where the total amount is greater than $300. So first things first, data investigation. Data investigation, which table answers this? And then which fields do I need to filter on to answer this question? So find the table first. Did anybody find the table? Or think they found the table? I probably did, I'm sure. Yep. Priscilla said, is it the orders table? It is, Priscilla. So select your top 1,000 rows from your orders table. Get rid of that limit. And now start building out your query. Build out on what you have. And we need a list of shift orders where the total amount is greater than $300. Kiana, you look like you done. You good?
Yeah, I'm good.
Okay. Kiana, I'm gonna put your second part of your use case in the chat. Okay. Same same other condition, shifting greater than 300. Nicole, Priscilla, Jackie, y'all good? Or did y'all want to talk through it? If y'all already have the where status equals shift and total amount is greater than 300, bring me only the orders for the year 2024 and order it by the total amount in descending order. Now, for that date range, use your between. And remember, we looking for that range. And in our natural language, it's like, okay, we'll say between 2024. But to be specific with your code, give it that range. What makes 2024? Oh, okay. It's between this date and this date. Let me grab some water, y'all. Hold on.